What's poppin', dogs? Mr. Allen here with some SAT math prep focused on concepts that you learned in Algebra 1 and before. And although that might seem like, these are kind of easy, I don't need to worry about that, you want to make sure you're prepped for those easy points so you can work through them quickly and spend a little more time on those difficult concepts. So don't sleep on these. We've got a handful of examples. Let's get it started with the first one. I have if 4x minus 28 equals negative 24, what is the value of x minus 7? So you could go straight through this one, solve for x, plug back in, subtract 7, or check it out. A lot of these are set up to where I could take out a 4, and I'm left with x minus, what's 28 divided by 4? 7 equals negative 24. I divide both sides by that 4, and you could have divided by 4 right off the bat if you wanted, but I wanted to show the GCF and that factor existing, and now I have x minus 7 equals negative 24 divided by 4 is negative 6. Is that an answer? It sure is. Choice C for the win there. Nice and quick. If you notice that like little group that's going to be right there, or looking for structure as it's sometimes referred to on your SAT problems, these come up from time to time. So be on the lookout when they ask you a weird question like what's the value of x minus 7 or what's the value of x plus y. You may have an opportunity to either multiply or divide by a common number to get that and not have to do all the crazy algebra. This one wouldn't have been too bad, but some of them, they get pretty terrible unless you notice that thing that you can find within the equation. All right, next one. In the given system of equations, a and b are constants. That just means that a and b are numbers. We just don't know what they are. The graphs of these equations in the xy plane intersect at the point 4, comma, y. So x is 4, y is just y. We don't know what it is. What is the value of a? So this might seem like, man, I don't have enough information because I don't know a, I don't know b, I don't know y. The only thing I know is x. But if we look at this thing almost kind of like the previous problem where we look for some kind of a similarity or something that we can take out of there that's the same, what if I divided all of this by 2? Wouldn't I be left with then, if I divide everything here by 2, I'd have 3x plus by equals 56 divided by 2 is 28. And doing a division sign across that equals there, that's technically illegal to do, but hey man, it's like street math. I learned math in the streets. Just wanted to be efficient. Okay, so now I have this by, and that's a by right there, right? And I do know that x is 4 here, and y is just y. But why don't I plug in 4 for x? So 3 times 4, I'll just write that right here. 3 times 4, that's going to be 12 plus by equals 28. And if I subtract 12, don't I get that by equals 16? Well, could I use that up here in this equation? Absolutely. So I'm going to have ax, wait, hold up. Isn't x 4? And by I know is 16, and that equals 72. So although I don't know what b is or what y is or what a is right at first, I was able to just get by because it's right there. I didn't have to solve for b and y individually. I got them together, and that's really all I needed. Now I can subtract 16, so a times 4, let's go 4a, equals 72 minus 16. That's what, 56? I believe so. Yes. 66, 70. Okay, cool. Awesome. Divide by 4. Let's see here. Divide 56 by 2 is 28 by 2 again is 14. A equals 14. And yes, you could use your calculator if you'd like. Choice D is there. That gives me confidence that the answer is there, and that's what we got. But there we go, guys. That's how I go about that one. It is intimidating because you have 3 unknown variables, A, B, and Y, and you're asked to solve for A, but you only have X. What? But because of how it's set up, and how we can find that by in there, you could have also multiplied this one by 2 and kind of done the same sort of thing. But I like to have smaller numbers so I can work without a calculator, but I've always got it with me just in case I need it. All right, hopefully that helps on that one, guys. Let's do another problem because these are just too much fun. All right, we got line P is defined by 2y plus 18x equals 9. Line R is perpendicular to line P in the xy plane. What's the slope of R? Well, in order to find the slope of R, I'm going to need to know the slope of P if they are perpendicular. So what we can do is, instead of dealing with this not so great form here, it's not even necessarily standard form. It's kind of mixed up there. But what I can do is I can put it into slope-intercept form. My goal is y equals mx plus b, because then I can figure out what my slope is, that m value. Okay? So I'm going to subtract 18x, and I got 2y equals negative 18x plus 9. Then divide everything by 2, and I've got y equals negative 9x plus 9 over 2. I don't really care what that is. All I'm focused on is the negative 9 right there. Now, if it said they were parallel, negative 9 is my answer. But it's asking for perpendicular. Do we remember how to get our perpendicular slope? It is the opposite reciprocal. So the opposite sign, which means it's positive, and the reciprocal. So instead of 9, it's going to be 1 over 9. So positive 1 over 9 for this one's for my perpendicular slope, which is the slope of line R. And we have choice, what do we got there? Ooh, choice C. Lovely. All right. So opposite reciprocal for perpendicular slopes. You see that one? That should be easy points for you guys, but it's easy to forget. Be like, wait, hold up. Do I just change the sign? Do I just flip it? No, it's both things. Opposite sign and the reciprocal. Flip it. And remember, you can flip an integer. You have 9. It's 1 over 9. Cool? Awesome. Next problem. Got a little free response here. We have if x over y equals 4 and 24x over ny equals 4, what's the value of n? Well, once again, we don't need to solve for x and y to get n. We have x over y already, and that's actually in this problem. I'm going to break this apart just a little bit here, help you guys see it. 24 over n times x over y, I'm going to put that even in parentheses here, equals 4. Now, if I know that x over y equals 4, couldn't I replace this with 4? So I would have 24 over n times 4 equals 4. If I'm multiplying by 4, could I just divide both sides by 4 right here? And that would cancel this 4, and that guy becomes 1. So now I have 24 over n equals 1. Well, how do I solve for n? Let's get it out of the denominator, multiply by n on both sides. Oh my goodness. We have n equals 24. It's beautiful. Cancel the n's there. Left me with just n on the right-hand side. 24 is it. Type it in. Move on. No big deal, even though it seemed a little bit scary at first. You got fractions. You got 2 equations. You got 3 unknowns. Not too bad. You got to look for those little chunks that are in those problems you can substitute in, not just for a single variable, but sometimes a product, a sum, a quotient of variables. All right, next problem. Ooh, it's time for some percents. All right, so we have in a sample, 80% of the items are faulty. There are 88 faulty items in the sample. How many total items are in the sample? So we want the total amount. Now, there's a few ways you can set this up, but I favor proportions in this scenario so I don't mix things up. So I have 80% is 80 out of 100. So 80 out of the 100 items are faulty, right? We have 88 items that are faulty, but I want to know the total amount. So I can put faulty items over my total items, x. And now I can cross multiply and solve. So we're going to have 80x equals 8800. That's not too bad. Divide by 80, and we're going to get x. So we will have 880 divided by 8. Let's just type it in our calculator right here. I'll put it all in. 8800 divided by 80. Boom. 110 items. So we have x equals 110, and it is free responsible to type that in. No big deal. We got it. And you can even check it if you want to make sure that this makes sense. If I did 88 divided by 110, I should get 80%, 0.8, right? There we go. So I prefer proportions whenever I have these like comparison statements. It helps me set that stuff up. Just make sure that your numerators agree. Faulty items, total items, total items. So numerators agree with denominators. Bippity boppity. Last problem coming right up. Ooh, we got some conversions to finish this video off. So we have how many fluid ounces are equivalent to 76 quarts. Now, they do give us the conversions, which is great because, you know, here in America, we got all sorts of different crazy amounts of things. Nothing really makes sense. No base 10. We got 8 fluid ounces equals 1 cup. 4 cups equals 1 quart. Of course. But we can actually use, once again, proportions to set this thing up. So I've got 4 cups is 1 quart. I want to know how many cups is 76 quarts. So I've got cups over quarts. Cups over quarts, okay? Now, the cross multiplication's easy here. You probably could have been like, couldn't I just multiply them anyways? Yes, I sometimes like to just set it up anyway so that I make sure I'm multiplying the right things together. So I've got x, 1x equals 4 times 76. Was that 304? Yes. 4 times 75 is 300. Add 4 more. Okay, so this is going to be cups. Always good to put units anytime you're doing conversions, okay? Now I've got, let's see here, 8 fluid ounces equals 1 cup. So we got 8 fluid ounces is 1 cup. I want to know how many fluid ounces is 304. So again, we probably could have just multiplied. But again, I like to be careful and use these guys. I don't know 8 times 304, 8 times 304. We've got 2,432 fluid ounces. Fluid ounces. OZ. Why ounces is OZ? I think I looked it up one time. I have no idea. I can't remember. Anyways, there we go, guys. Conversions. For this one, yeah, you could have just been quickly like, oh, 76 times 4 times 8. But again, I like proportions because sometimes the things don't quite line up as you thought in your head and you end up getting it wrong. So proportions for the win. For me, anytime I'm comparing things, I have two comparison statements. I like to set up a proportion. Helps me stay organized and make sure I'm doing the math correctly. But anyways, guys, if you have any questions, requests for other videos, whatever you want, pop it in the comments. Otherwise, thank you guys so much for watching, and I hope you crush it on your SAT, whenever it is that you're taking it, retaking it, or whatever. And if you guys are taking the ACT as well, I have some ACT math prep videos, and it is quite different from the SAT, so make sure you check those out and make sure you're prepped and ready to rock and roll. All right, have a great day. See you later.